Good morrow, fellow humans. My name is Sean Crowley and I am obsessed with infinity. So join me as I attempt to unpick the infinities of what is. In our day and age, it's practically considered common knowledge that in the universe's earliest moments, the wholeness of nature and the entirety of everything was contained within an infinitely compressed point. But what does that really mean? The problem with thinking about the universe as an expanding bubble hanging in nothingness is that it forces us to either declare or abandon the actuality of nothingness. Many concede to this notion of nothingness by referring to it as merely the absence of things, a dimensionless non-spatiotemporality untouched by the ever-expanding bang. However, they will often then go on to grant this particular brand of nothingness the attribute of a potentiality, as in a nothingness capable of becoming an isness. But this isn't nothingness. At best, this could only ever be considered emptiness. And so philosophically, it becomes impossible to adopt this concept as a genuine example of nothing, since if it were an ultimate example of nothing, it would not host potentiality and we wouldn't be here. Now, sadly, this shall not be a discussion about the existence or non-existence of nothing. That's just going to have to wait. Because what we are still attempting to shine a light on is how time relates to change. Here, we are unfolding a relevant issue that arises when we declare the existence of an ultimate boundary, or worse, confuse infinity with one. So often in physics, the word infinity is used haphazardly in place of some extremely large or uncountable number, such as in the phrase tending towards infinity, often used as a catch-all to describe an event that builds exponentially. In reality, however, everything tends toward infinity. 1 tending towards 2 is still tending towards infinity. But more importantly, 1 tending towards 2 is just as close to infinity as is an exponential increase that leaps from the tens to the trillions within only a handful of steps. This just goes to show how much we are in the habit of confusing non-digital concepts such as infinity with digital ones, like ultimate borders, like those thought to separate banging bubbles of space-time from the hard-edged fringes of nothingness. As that philosopher Parmenides once wrote, nothing comes from nothing. And so, faced with this perplexity, many have chosen to dismiss nothingness altogether. But what then is our floating finite bang set within? In many of today's cosmological theories, we are asked to envision a description of nature that persists beyond the universe, outside of space and time. Here we are asked to imagine a domain capable of housing a potential infinite of universes, each with their own unique set of physical laws, separated by what could only be described as an ethereal isness of non-physicality, what we might call budget nothing. But even if we accept the possibility of such a domain, what is the nature of the boundary that divides us from it? Now, it is possible that we could live in a universe whose nature is both finitely bound, but also without end. We will try to navigate such a universe in later chapters, but for now, All we need to know is that a universe of this nature would never find its end, because at one point it would begin repeating itself. Though this might not be as counterintuitive as it first appears, akin to how a straight line on Earth, having never turned around or left its flat two-dimensional surface, will eventually return to its starting point. The universe could similarly be curved in higher dimensions, allowing straight lines in space to also come back upon themselves. In a cosmos of this nature, we would never find a boundary separating our three-dimensional space from the faux nothingness, but nevertheless, the issue remains. Even in this model, our universe is still considered finite, meaning it must be bordered in some way or another. Often these mathematically derived physical theories describe the tapering off of physical reality where space-time falls down infinite ravines that are shaped by the universal constants of nature. Upon the fringes of the uncertainty principle, the speed of light or black hole horizons, where we often, once again, confuse these infinities with ultimate boundaries. We, as macroscopic entities, may be held back by them, sure, but that's not the same as saying that reality stops. Now, there is a small thought experiment that we can take from the last chapter, which in a peculiar way is actually very relevant to this same idea. This is the deceptively simple mathematical conundrum where a 10 divided by 3 fails to return to 10 after being multiplied by 3, leaving us with the untidy 9, followed by an infinite recursion of 9s. Now, let me just reassert my own inadequacies in mathematics and reassure you all that this shall be brief, painless and simple, but in the end, philosophically intriguing. Because there is actually a mathematical proof that tells us how an infinite recursion of 9s should be considered equal to 1. The proof works as follows. X is equal to 0.999 recurring. Therefore, 10x is equal to 9.999 recurring. Now, if you simply start with 10x and then subtract 1x, you will have 9x remaining. What this is saying is 9.999 recurring minus 0.999 recurring is just 9. But if 9x is equal to 9, well, then x must be equal to 1. Thus, 0.999 recurring is equal to 1. So what's the point? The point is that this so-called proof is actually an excellent one to meditate on because it forces us to ask, what really is the difference between an infinite recursion of 9s and 1? In one sense, the infinite rational fraction seems to fall short of 1 since the recurring 9s are never resolved. To say that they are 1 is to say that the 9s found some end. And yet, in another sense, they must also be infinitely close to 1 with absolutely nothing left to be added. The chasm between 0 and 1 must be infinitely full. And so, what we are forced to ask is, what's the difference between infinitely close and arrival? Or, as it's relevant to our current topic, what is the difference between the infinite ravine of uncertainties, light speeds and black holes, often confused as borders, and continuation? But of course, as many of you may have already reasoned, this divide between space and nothing only remains an issue so long as we presume that the universe is finite. If, in contrast, we assume that our four-dimensional universe is instead infinite, well, then we have no need for a nothingness that is. nor any ultimate borders. And this is actually the more common belief, that space and time go on forever. But this brings us to the reverse issue with our bubble-like interpretation of the Big Bang, as we now have to account for how this tiny singularity could expand into infinity within a finite amount of time. Since if we were to rewind our universe at exponential speeds from where its current infinite girth might rest today, back in time towards its singularity, we would never reach any starting point. It would, of course, continue rewinding for an eternity. On occasion, I have heard the odd expert claim that if we had an infinite amount of time, the universe would then be infinite. But this, as a statement, is utterly meaningless. Because if the universe had a start, it could never reach this infinite state, neither in time nor dimension. Even an eternal universe would never achieve these infinite ends. Thus, we are at a crossroads. For if the universe is finite, then we are forced to deal with the paradoxical nature of a nothingness bordering space and time. If infinite, then a finite Big Bang singularity would also prove paradoxical. But what if we were to consider the infinite compression of the Big Bang, not only as containing everywhere and everywhen, but also being everywhere and everywhen? Instead of it being an infinitesimal bubble, imagine the Big Bang singularity itself as that which is already infinite. A singularity without bounds. Not as some beyond sub-quantum grain, but as a literal infinite place, just as everywhere and always as is the universe today. To use a clumsy metaphor, an infinitely large singularity. But though we are, once again, forced to use metaphors, this one, in particular, does now feel somewhat familiar, as it parallels the other thought experiment from the previous chapter, which was our attempt to remove the language of scale from our infinite mathematical sets. There, we considered the infinite numerical sets not as hosting the attributes of largeness or smallness, but more qualities that were relevant to the observer, such as closer or further away, denser or sparser, depending on which finite frame it was that we wished to consider. And so it seems that we could play with a similar dimensional transition here, only this time in the context of the compressed infinite universe and the decompressed infinite space-time. Instead of thinking of the universe and the singularity as being bigger or smaller than one another, we can think of them as being compressed or relaxed versions of the same infinite wholeness. In its compressed state, the universe could potentially host a nature not too dissimilar to that of quantum foam or the inner depths of black holes, and therefore be safely considered dimensionless in the traditional Newtonian sense. Whilst at the other end of the spectrum, in its relaxed state, the universe unfolds into what we see today, unwinding the quantum randomness into the traversable dimensions of space and time. To imagine this, we only have to see that the universe doesn't grow in size. It expands within itself. The retreating galaxies we see aren't riding a wave of space-time away from us. Space is expanding from within itself. We see this when we look up at our night sky, an expansion revealed to us in the red-shifted light of ever-receding galaxies. So let us consider a Big Bang that didn't just happen everywhere at once within a finite singularity, but one that happened everywhere at once within an infinite singularity, one which, by this rationality, we must still be within today. Therefore, the image of the explosions racing through an empty void that you probably had in mind when thinking about the Big Bang would be entirely fictional. For this event didn't just happen within some void of nothingness. It happened everywhere, infinitely. Now, we mustn't confuse this with the fact that the traditional description of an expansion rushing outwardly from the original Planck-sized universe is still technically accurate from a certain point of view. It's just that the so-called Planck-sized universe refers more to a state of compression rather than size. Size, as we tend to think of it, is just simply not relevant when imagining this compressed state, as size is itself an attribute of nature that only became relevant with the emergence of our three-dimensional space. Prior to the emergence of traversable space, size was not a valid variable. But from the moments just after its initial birthing, we can safely say things like the universe was the size of a baseball, but only with respect to the part that we call the observable universe. These tiny universes that we so often hear about in science documentaries are not the universe in its entirety, but only a small version of the bit that we see today. And so, within a model of this nature, I'd like to think that there kind of was no Big Bang, only what I would call a big relaxing, where from within some unique perspective of reality, a new dimension did open, allowing for space and time to become appreciable, but importantly, nothing new was added to reality in these first moments. This was just the emergence of new relationships. And just to add one further level of complexity to this ponder, though this may have been an infinite opening, relaxing an infinite of spatiality and temporality into existence, we could still consider this universe dimensionally contained, not by any ultimate borders or spatially defined edges, but by a transition of relationships pulled taut by the infinite ravines that we recognize as the laws of nature and the universal constants. A loose bookending of space-time, shaped by quantum uncertainties, light speeds, and black holes. And so from broader perspectives, a universe, whether endless or limited, could be considered much more like the borderless atom or the haze of poor weather that sits upon the mountaintop, each unique and individual through one set of eyes, whilst equally entwined and at one with the wholeness of reality through another, offering us a picture of reality quite reminiscent of our mathematical sets, with infinities harbouring infinities. Of course, this is purely hypothetical. But then, so is every theory concerning the universe in these earlier states. But if nothing else, I do hope that this short series of thought experiments has given you a taste of what considerations are forced upon us when we acknowledge the infinities that lie hidden behind a label of boundary, since we can never almost be at infinity. Infinity either is or is not. So, what does any of this have to do with time and its relation to change? Well, as we might recall, these ends of time are the domains where change appears lost and time is declared null. Now, if you were to specify that this temporal cessation refers solely to time as we know it, well, then you might have a case, since then we were talking about something particular to our perspective. Or even this would require a knowledge of what time as we know it is. If we were to declare that time is nothing other than an aspect of change, flow, or flux, then all we have to ask is whether these qualities find themselves up against ultimate boundaries as they sink down into the infinite ravines described by physics. Do they meet the walls of nothingness? I think not. Reality doesn't begin or end with singularities. It just shifts gears through them. As Stephen Hawking famously remarked, asking what was before the Big Bang is like asking what is north of the North Pole. It's not that the answer is nothing, it's that the question is wrong and that we must continue our search for those better questions. And so in truth, we can't yet say what time was like before the Big Bang, nor what it will be like during the photon age following the heat death of the universe, since, if we're being brutally honest with ourselves, we don't even know what time is now, beyond our very human experience of it. Because just like the mirage of ultimate borders, time as a thing unto itself can only ever be appreciated in relative terms. So if we wish to consider the topic of time properly, then it now seems abundantly clear that we must first determine what perspective we are considering time from. From what perspective are we choosing to claim that time either does or does not exist? That it is equal or not equal to change? Albert Einstein described his own perspective of space-time as an expanding infinite universe within which all points are relative, with no universal bed where space lies, nor any universal clock. A place where we move through space and time only in relation to other bodies. Thus, without the bodies, things, elements, or energy, there would be no way of appreciating any state of space, time, or even change. But that is only from this perspective, a perspective that assumes we could remove all energies from the universe, a perspective that presumes the possibility of another type of nothingness. From all imaginable frames, will we be forced to claim that change stops? Is time digital, like the mathematics we use to describe it, and hence capable of some final moment before being compressed into oblivion? Or is it analog, boundless and eternal? Does it roll from start to end like a bike down a hill? Or is it infinite, not only in its duration but also in its density and depth? At the ends of matter in the universe, it's clear that time does appear somewhat missing. But this is only because there is nothing relevant to our perspective that could show evidence of it. If we were to travel into the future and witness this universal heat death for ourselves, we would of course still experience time. But this is because we are the movement by which time is measured. We are the frame through which time would exist. From this perspective, we are time.
Thank you so much for listening to the episode. I just wanted to offer a massive round of thanks and let you know that the YouTube page is currently up and running, and that's giving weekly visualizations to the same readings that's happening in the podcast. So if you want to go over there and check that out, that is, again, Infinite Now with Sean Crowley. So hopefully I'll see you there week by week. Apart from that, much love, and I hope you have a lovely day. See ya.